things up.
Good afternoon, everybody. Welcome to class this afternoon. Thank you for joining me. Whether you are watching the recording or you are here with me live, I appreciate you watching. Thank you for taking the time to get involved. Right, and so as we progress along here, it's kind of important to point out, the further we go, right, the further we're just adding tools to our toolbox. And so it does kind of increase in the level of challenge that we're dealing with here. So we need more and more tools to complete tasks. And we're adding another tool to our toolbox in the upcoming module, right? Your Module 5 assignments are due tonight by 11:59 p.m. Your Module 6, or Module 6, I should say, kicks off tomorrow, officially. And that's what we're talking about today. We're talking about Module 6 material, which is in regard to string manipulation. So let's talk about what string manipulation is and how we can use it in a program and some of the things that we can do with that will help us to advance our programming knowledge. So I think the first important thing to do is just to do a little bit of review, right? Because if you remember back at the way beginning of the course, right, we talked about what exactly a program is, and we talked about it being in relation to computations, right? We said it was, some statements that performed some computations. And then we started talking about what a computation is. And we said that a computation could be, the regular sort of mathematical arithmetic computation that we've been working with so far. But we also said that it could be alphanumeric. And we could be performing some alphanumeric computations. Which essentially what we were talking about there is performing computations with strings, right? Being able to do string manipulation, to use string-based data to calculate other things, right? And working with strings to get information from said data. So as we approach working with strings now and doing string manipulation, it's important for us to kind of go back and redefine what a string is and what we're actually seeing when we see a string. Because we've worked with strings a lot before, right? Like we've put a bunch of strings in our programs. We say that anytime we take text and we wrap it with a pair of quotes, that turns it into a string. But we've never really defined what a string is, and we've never really used them outside of like text-based labels, right? And so with this module, all of that changes. But a string can be defined as a sequence of characters. Right, and actually in terms of how we use a string, that is incredibly important. It's incredibly important for us to understand a string as a sequence of characters. And characters in a string are arranged in a particular position. right? So when we're looking at a string, we're not just looking at a word, we're looking at the ultimate culmination of a series of characters put into a word. And actually, if we go way back in programming, like if we go back with like C, in the early days of C programming, there's really no such thing as a string, right? We have to actually kind of break things down into the sum of its parts and string them together. And a little later on, they would add some string functions that would help stringify things. But when we're looking at a string, what we're really seeing there is just each individual character that our computer takes, converts it into ASCII, and then displays it, each of these individual characters just in a row. And this is a position, right? So when we refer to this and we say a string is a sequence of characters, we can actually access each character within the sequence one at a time using our bracket operator, right? Our square brackets. And so we have an example here, right? We have a variable that we're creating. We're giving it the name of fruit. And then we have a letter here where we are pulling out the value at index location 1, right? The expression in our brackets here is called an index. We're pulling out the information here at index location 1, and that's pulling out that singular character that is inside of this string. So if we look at this in a sort of way, right, we kind of look at our term banana, right? We take and look at B A N A N A, right? We have the term banana. And we say banana is our string. So let's just write it up here at the top as well, so we can kind of have an idea of what's going on here. We have our string banana. And we say this string is a sequence of characters, so we can take out and break out all of these characters into their own location. And we can kind of look at these different locations as if we were looking at a house, right? Each of these characters in this string has a house that it lives in, right? Because each of these characters in the string take up a little bit of memory, right? So they have to have a location in memory where they're at. And so the thing about a house, right? Every house also has something else. Every house also has an address, right? So if we say that all of these characters that are a part of this string lives in a house, then all of these houses have to have an address, and that address in relation to our string is the index location. And so by default, whenever we create a string, every character in that string has its own space in memory, and it has its own address. It has its own index location as a part of that string, right? And so when we look at this here, we actually know the index locations. We know the addresses for all of these items, right? We start counting at our first letter with 0. So the address, the index location for our first letter B here is 0. And then we go up from there. 1, 2, 3, 4, 5. Right? So when we look back at that last screen with that last example, and we were looking at the string banana, and we were looking at the first index location of what's in that string. So Remember when we're dealing with this here, right? This could be the name of a variable, and we're looking up the index here, or it could be the string itself, and we're looking up the index here. Remember that when we're working with a variable, all that's doing is going back to the variable, getting the data out of it, and pulling it back. Right? So when we look at this, we're essentially saying, let's look up, let's find who lives in house number 1, or house at the number 1 address, which is here. So if we evaluated this in our program, this would return the letter A. Right? Our number 1 index in the word banana is just the letter A. So when we're looking at our string index and we're looking at manipulating strings, this is an important thing for us to realize, that each letter within our string has a place, and we can quantify that place with a number. Now, we can also look at these in the negative direction, right? We can kind of think about it as a number line in that regard, right? So if we have our number line and we start at 0 and we count up, etc., we can count the other direction, which would start us at the right here, and it would allow us to count down, starting with -1. So it'd be -1, -2, -3, -4, -5, -6. So not only do our houses have one address, they actually have 2 addresses. We can refer to them in either way, right? And we can actually see this in action if we head over to a replit, which let's do that really quickly. Find my replit window here. Way too many windows open. And we can take and we can go ahead and just add our shebang out of good practice. And we can create a variable. Let's call it str_variable. And we can set it equal to the word banana. Right, and so from here, we can take and we can print out the values at each location. Right, so if we're going to print out string_variable at index location 3, right, this is going to give us the letter at the 3rd index location address, which in this case, B is 0, A is 1, the first N is 2, the second A is 3. So this here, this second A is the A that we'll be getting out of that. So if we run this to the console, we see we get the letter A. And just to make it even clearer, right, we can use something, we can use a word that doesn't contain multiple characters, like we can use the word Python, right? And so in this case, it's the same situation, right? It's just a different string. We still start counting our addresses at number 1, right? So we have 0, 1, 2, 3. And in this case, the item at our 3rd index location is H. And so if we run that, we get H, just as we expect. And we can also go the other way, right? Like if I want to select the H going in the negative direction, the negative direction starts from right and goes to the left. So that's -1, -2, -3. So this would just be a -3 here. If we wanted to select the T, we'd start at we'd go to -4. Right, so let's do that instead. Let's find the letter at the -4 index location, which is going to be our T. Right, and so that's the basics behind selecting an individual character within a string of characters utilizing our index locations. Right, so just so we see that again, let's go ahead and just put all that data, put all that information back up here, just so we can get string indexing here formally introduced into the video in our slides so we can have that written data here. We see that another way to analyze a string is to use the indexing location. So indexing is a way to reference individual elements within a string based on their position. So you can create an index by placing an integer value inside of a pair of square brackets after your string variable, just like we were doing there, right? Like we made our string variable, right? We called it string underscore variable. And then we were able to pick out a particular letter out of the inside of that string by using our index location. Indexes always start with 0, right? So that very first character, when we're counting in the positive direction, is always going to be 0, and it's always going to start with 0. And that is one of the most important concepts that we can kind of keep under our hats for the remainder of working with programming, right? Is that this idea of indexing always starting with the 0 value. Because that's going to impact the way that we deal with other things down the line. And so when we are referring to things in a string, we always consider them to be the 0th, 1st, 2nd, 3rd, 4th, whatever of that element. And as we've seen here, we can also index backwards. So when we index backwards, the last letter of the string going from right to left then becomes -1. And so -1 back to however far we need to go to get back to the first letter. Now this gives us a lot of power, though, right? Like it's not just, kind of important to work with strings here to be able to just kind of print out the characters or whatever. This gives us a lot of power, and this gives us the ability to start to make some alphanumeric calculations. Right? And the big thing that this allows us to do is it allows us to index to iterate over a string. Right? And we started talking about iteration last week with the while loop, and we can still use the while loop here. We also introduced the for loop in this module and different types of the for loop. But we can iterate over a string and we can access different characters within that string and choose to do things based on what those characters are. Right? And we'll see some examples of that in just a moment. Right? And one of the things that we can do here is we can use the len function to count the number of characters in our string, because we're not always going to know the number of characters in our string. Right? Most of the time we're going to be getting a string via an input. Right? So if we want to be able to iterate over this string without first knowing how many characters are in the string, we need to be able to have a way that we can programmatically count all the characters in the string, and we already have a function built into Python that does that for us, which is the len function. And so there we can use a for loop, or we can use a while loop, either one. I'll show you examples of both. To set our lower and upper limits for the loop and iterate over the characters. So I'd like to do two things here. I'd like to show you an example using a while loop, and in this example using a while loop, what I would like to do is I would like to take and reverse my string. And then I'm going to show you an example that uses a for loop, which is new to us, that will take and replace a string or replace a character in a string with a new character. Right? And we're going to be doing that the manual way first, and then later on we'll show you the automated way to do that. Right? So I'm going to go ahead and just comment this out here just for our sake, right? We got that. It's easy enough, so we can kind of move on to the next thing. And so let's just write ourselves a function that's going to reverse a word. Right? So we're going to write a def reverse underscore word function, and I'm going to take in an argument of word, right? We'll get the word somewhere else and we'll pass it into this function. And so what I'm going to do here, and one of the key things to know about strings in Python is that strings are immutable, which means they can't be changed. So if we want to do something with a string, we have to address it to something else, right? So if we want to change a word in some way, we need to have another variable that's going to store that changed word. Right, so in this case, I'm just going to create a variable container, set it equal to an empty string, and that will give us the opportunity to work with this string and change it into something else. Right, so what I want to do here is I want to iterate through the length of this word, and I just want to concatenate whatever I have currently in the value of changed word with my new letter in a way that it will reverse it, right? It'll put the first letter at the end, and it'll put the last letter at the beginning. So in order to do that, I can iterate over this loop, and I can create myself a variable. That's my counting variable. So I'll call it C here for counter, set that equal to 0. And I will establish my while loop. So I can say while C is less than the len of word. And so the len of word here allows me to, even when I don't know the word, this will allow me to get to the length of the word. Now you might be wondering, why did I use less than instead of less than or equal to or some other comparative operator, right? Remember, the key thing here is that we start counting our index locations. We start counting those addresses at 0 instead of 1. Right? So the length of our word will always be 1 more than that final index location of that last letter. Right? So if we go up to but don't include the length of the word, that will give us the index location for the last letter. If we were to set this as less than or equal to, that would give us an out of range error because we actually don't have a house with the address of that full word length, right? Because it's always going to be 1 less. So all we want to do here is take our changed word, and we could set that equal to the letter that's at the current index location, right? So if we're counting these numbers here, 0, 1, 2, 3, right? It'll be word, index location C, and concatenating that with what's already in changed word. So it'll take what's in changed word, and it'll concatenate the new letter before it. So it'll be flipping the word around. And then we can just add 1 to the value of C. C plus equals 1. So if we look and we break down this loop, right? What we're looking at here first time, C is 0. So we're addressing word at index location 0. Then we add 1 to that, so we'd be addressing word at index location 1. Word at index location 2, etc., etc. And all the while, we're adding to that what's already in the value in changed word. So it's just taking and adding this letter to the beginning of the word. So if from here we were to print changed word, we would be printing the reversed value of the word. So now if we go behind our main gate, if underscore underscore name underscore underscore equals equals, in quotes, underscore underscore main underscore underscore colon, we'll take an input, set the value of new word equal to the input of enter a word to reverse. And then we'll take and pass that value inside of reverse word. So that's reverse word with the value of new underscore word. All right, so if we take and run this now, we're asked to enter a word to reverse. We can enter in something like apple, and we get back ilapa. Right, it's taken my word and it's reversed it almost instantly. Right, you can see how fast that's done. Right, we can take something that's even longer, right, since we're using that dynamic len to get the length of the word there. We can make it as big or as small as we want. So even if we, put in a long word like microphone, it doesn't matter how long our word is, it'll still take our word, flip it and reverse it, and give us back the flipped word, which is awesome. Right, and so that's the kind of thing we see as we're iterating a string with a while loop. Right, we have these computations that involve, processing a string one character at a time, right? Like we just did there, where we took our string one character at a time and we put it one character at a time into a new empty string, because we can't change that string in place because a string is immutable in Python. So that string is always going to be there. So we have to take it and store it to some temporary or some kind of other holding variable. So we can use a while loop to take and iterate over each letter at a time in the same way that we were working last week with while loops, right? We have a starting value and we have a terminating value, and it's all based on those addresses. It's all based on those index locations. So I can say 0, 1, 2, 3, 4, 5, right? If you remember back to last time, right, we were talking about having a starting point, having a goal, and then moving that starting point to that goal. Well, your starting point typically is going to be your starting index location, which is either going to be a 0 or a -1, depending on how you want to address it. All the way down to your ending goal, which is going to be your length of the word. Now, one of the interesting things that we could do here, right, is we can take advantage of this in a similar manner, counting the other direction. Right, like if I wanted to take this and change my logic up slightly, I think it's pretty interesting. Right, all I would really need to do is change this to a greater than or equals. And then I can take my length of my word and multiply it by a -1. Right, so then, remember when we go the other way, we start counting at -1. So we'll go down to the negative length of the word. And so in this case, we could actually take and do a -=1. And then just change the way that we do this, because we're going to be starting with the last letter and then going back to the first letter. So we can say, we can actually take this and truncate this down to plus equals word at the index location of C. Right, and that's going to do the exact same thing for us that we were doing before. Right, again, we'll point that out again, that's one of the most challenging things when we're approaching the idea of programming, is this fact that we can do things in multiple ways. And we're trying to get these tools in our toolbox. And, it's one of those things where, like, I teach you all the tools, and then you have to go build a house, right? Like if you go out to construction sites, let's just go down this side road for a second. Go out to a construction site, right? You go out and you see, 2 different houses being built. You might go somewhere and you see like a massive 3,000 square foot house being built. And then you might go somewhere and you see a really small, like 600 square foot house being built. Both of those houses are entirely different, right? They have completely different purposes. They're for completely different people to do completely different things. But if you look on the construction site, the tools that the construction workers are going to be using are all the same, right? They're just applying them in different ways to create different houses, right? They're going to have power saws. They're going to have power drills. They're going to have hammers and nails and all that sort of fun stuff, right? The tools are going to be universal. The way those tools are applied is going to be different from situation to situation to situation. And that's what programming is, basically. So we can see this in action now if we want to, right? We can take and we can enter our word to reverse. Let's try out the word headphones. And that also added, oh, it's because I'm starting at 0 here. I need to be starting at -1 in this case. Yeah, so now if we do headphones here, we get the reverse of headphones. Right? So exact same program to reverse a word done 2 different ways. And using our while loop is just one loop that we can use here. Another one is our for loop, which is actually a very common way. This is actually a very common way of iterating over a string, is to use what we call an enhanced for loop. The for loop that you see on this screen is an enhanced for loop. So it's just a little bit different. Right? So when we're using a for loop, the for loop is going to traverse the string and kind of put each letter kind of on line by itself, right? So when we use an enhanced for loop, like we've done here, by using the term in, we're essentially saying for some variable name, right? We have to create some variable name here. This needs to be a unique name depending on the for loop. So for some character in fruit, or for L in word, or for whatever, right? We're going to print that character. And this is going to iterate over that string, and it's going to pull out each individual character. So each time through the loop, the next character in the string is assigned to the variable char, or whatever variable that you use there. Right? And the loop is going to continue until there are no more characters left for it to deal with, right? So this is going to create us, an easier way to kind of get through a loop. So the other thing that we said we were going to do here was we were going to change a character in a word based on whether or not that character existed. So let's create another function for that. And I'm going to create a def change letter. And we're going to bring in the value W to stand for our word. Right, and so what we're going to do here is we're going to iterate over that word using an enhanced for loop. So I'm going to say for L in W. Right, and remember that up until this point, L does not exist anywhere else, right? This is not a variable that's being used anywhere else. This is a variable that's specific for this for loop, right? And I can call this whatever I want to call this. I can call this letter. I can call this hat for all I wanted to, right? Doesn't matter as long as I'm consistent. In fact, just to prove that, let's leave it at hat. We can make a comparison here. If hat equals, let's say, A. Then we'll take and we'll concatenate. We'll do the similar thing that we did before, where we took an empty string and concatenate it with a word that already exists. So let us create an empty string here. We'll take a value for, we'll call it changed word again, and we'll set it equal to an empty string. And so then we can take that changed word plus equals X, right? So this will add an X in place of an A if that letter is A. Otherwise, else, we are going to concatenate the value that is the current letter, which in this case would be whatever letter is contained in our little variable hat. So changed word plus equals hat, like so. And so this is all we really need to do here, right? And so we can now reverse our word, and we can also run this function here. We can just add a little print statement to print the changed word, or we can return the changed word and print it behind our main gate. Either one. So we'll just print changed word, and this will take the character out and put the different character in. So now if we add our reference to our change letter function here, change letter, and also give it the argument of new word. Now we're able to reverse our word and make it go backwards, and we'll take any letter A's that are also in our word and replace them with something else, in this case the letter X. Right, so if we were to enter in a word like, let's say absolutely, then we can see here on the first line we have the reversed form of absolutely, and on the second line we have absolutely, right? Because it's taken and replaced the letter A from the function with the letter X. And we can do that with whatever word that we want to, right? Like if we display, where it would have the value A inside the word somewhere, we get display backwards, and we can see we have X instead of A here, right? And so that's the utilization of an enhanced for loop to do something with our string. Now, obviously, right, like if we wanted to get rid of, in this instance, we're concatenating the letter that we want to replace the letter A with in its place here, if that letter is the letter that we want left out. Right? We could concatenate an empty string with that also, right? We could say display, and then it's just going to get rid of the A altogether. And so this is the manual way that we would remove a letter from a string if we were working with that. So this gives us two good examples of some actually practical alphanumeric calculations to work with here. Now, in addition here, another thing that we can do is we can use relational operators to strings. Right, which is kind of interesting that we can use a relational operator to strings, but this kind of goes back to the stuff that we talked about before with ASCII. Right, because when our computer sees this letter, right, it doesn't actually see the letter. Yeah, it sees the ASCII value of that letter. So when we make these comparisons, and we can say, like, apple greater than banana, and we get a true or false Boolean return from that, that's based on these ASCII values of the letters. It's going to go letter by letter, making a comparison until it finds one letter that's greater than or less than the other. And then it'll say, oh, apple comes before banana because A comes before B, because A has a lower ASCII value than B. Now, the important thing to remember here, though, is that, you might want to do some data validation with this, which we'll talk about in just a little bit. And that's the fact that if you'll remember back to when we looked at ASCII charts before, uppercase letters come before lowercase letters in the ASCII chart. So if you'll see here, like with the fourth bullet point, we see, pineapple comes before banana because it started with an uppercase P. Right? Those uppercase letters have a lower ASCII value than lowercase letters. So if we have an uppercase letter versus a lowercase letter, that uppercase letter always comes first. Right? It all comes back to that ASCII value. And one of the common ways to address this problem is to take our strings and convert them to a standard format. Right? We can make them all title case, all uppercase, all lowercase, however we want to deal with it. Right? And we'll have another look at that here in just a little bit. I'll show you how to do that. And so we've already seen a practical example of this. But we can count while looping through a string as well, right? So for every letter, we're just increasing a count. This gives us a lot of flexibility, right? Because one of these things that we can do here is we can count how many vowels are in a word, right? So let's do this, and let's look at another example of a for loop that we can use here, which is going to be a for in range loop, and we'll see how we can use this with we can use our in keyword with an if statement. So if we look at this here now, right, we've got our reverse word, we've got our changed letter, and let's write another new function that's going to count the vowels. So we'll call it def count vowels. And we're going to take in the word as the argument. So we can write for letter in word, like we've done here. Another way we can do this, which would be more similar to the way that we worked here with our while loop, would be to use a for in range loop. For I in range 0 to the len of word. Right, and again, this is going to give us the number for an index location. Right, because we're looking for a number that's in this range from I to the length of the word, or from 0 to the length of the word. So when we use a range like we're doing here, we're counting up to but not including that last number there. So it's like using less than. Right? So essentially our for in range, if you've programmed in other languages, this is a standard for loop in other languages. It's just written slightly differently. Right? We have the starting value, which, just like here, we started with the starting value. We have the ending value, which we put here. And then by default, your incrementation value is 1. However, we could also define a third argument here to change the incrementation value if we wanted to count by 2s, 3s, 4s, 5s, so on and so forth. We'll do an example with that in the next module, next week. or we approach some of that. So now we're getting an index location for each letter in the word. So then we can see if this particular letter, so if word at the index location of I in another string, right? So we can make another string. We can call it vowels. And we can set that equal to A-E-I-O-U. So if word at index location I in vowels, which is essentially just saying if this letter is also in this other string, then we can increment a counting variable. So let's just come up with a counting variable and set that equal to 0. And we can just count plus equals 1 and print count, right? And this will count the number of variables that exist in our word. So now we have 3 functions here that do 3 different things. One will reverse our word, one will change the letter that is a part of our word. It's going to change A's to X's, or it's going to change A's to blank spaces. Now it's going to remove A's. And we could do that again with count vowels. With the value of new word. And that will count all the vowels that are in our word. So enter a word to reverse here. And we could change this to be like enter a word to manipulate. Right? In fact, let's do that while we're thinking about it. Enter a word to manipulate. And also, let's just add like some kind of concatenation value here. Vowels are in this word. Right? So enter a word to manipulate. Let's try manipulate. So we have 2 A's here, so we should be able to remove both of these A's with the code that we've written. We have 1, 2, 3, 4, 5 vowels, so we should get a 5 off of this count vowels function. And we should get the word manipulate reversed. So there we go. Italapanam, which is manipulate backwards. We see manipulate there with both of the A's removed, and we see that 5 vowels are in this word. So these are 3 different practical examples that we could use here to do some alphanumeric computations with strings in doing string operations. And in each case here, we've done a different way of iterating over the word. And in iterating over the word, we are in iterating over the word, we're able to access each letter one at a time and deal with it that way. And so that's what we're doing here when we're accessing the string. And so we have an example here right now. Like, let's take what we know so far and write a simple program to count the number of S characters in Sally sells seashells by the seashore. And that's just another example of kind of what we were doing there, right, with counting the vowels. You know, if we were to do this, all we would do, and I'm going to not do this right now, and I'm going to leave it as a challenge for you, right? What I think you should do right now is pause the video and write a quick program that will count the number of S's in the phrase Sally sells seashells by the seashore. So you'd want to be able to iterate through that phrase, which, you know, it's just a string, and our string is going to be that sequence of characters. Right? And then every time you encounter the letter S, whether it's an uppercase S or a lowercase s, you're just going to add 1 to a counting variable. And then by the time that's done, you have Sally sells seashells by the seashore, you have the number of S's. Right? Because, that allows us to take, we're essentially doing the same thing there, iterating over the string and getting the characters out of it. Now, the issue then becomes, right? Well, we've started this off with this uppercase S, and then all of the other S's are lowercase S's. So what we want to do here is we want to be able to take this word and we want to change it and normalize that data. And I talked about the upper and the lower. Right? And there's also another function here that we might use a little bit later on called title. It operates the same way, and it title cases our words, which means that every word would have the first letter capitalized and the rest of the letters lowercase. But for our purposes right now, for doing a little bit of data validation, using our dot upper and dot lower functions allows us to normalize our data. So we can see here, if we want to take our word and we want to convert everything to an uppercase letter, we have to assign it to a new variable in order to get it to work. Right? That's going to be our best practice here. So we have our word banana. And in a new word container, right, because we can't change it in place, because our strings are immutable, we can put into a new word variable word.upper, and that will put a string in there that would be all uppercase letters, which is beneficial. Conversely, word.lower, we'll take that and convert it to all lowercase letters. So for example, if we look at our program here that we're working on, we have this here where we're finding the letter A. But if we put in like the word apple and we started out with an uppercase letter, it's still going to have that uppercase letter A there because we're not checking for that. We're only checking for A. Lowercase, right? So where we put this assignment, right, is going to be different depending on the program. But in this case, I can take it and just stick it right here in this if statement, in this conditional statement. So I can say if hat, which in this case is the letter at that iteration through the word, dot lower, with parentheses after it because it is a function. So that would take any word, any letter that we put it in there and make it lowercase equals A. And really, I could do the same thing here. And I can say if word I dot lower in vowels, right? Because all my vowels here are all lowercase. So if I started with an uppercase vowel here, like happened here, right? It says I only have one vowel in there, even though I have uppercase A and lowercase e. It's only counting lowercase e. All right, so now after I've added some data normalization here and have these converting to be lowercase letters at these different places, I can enter that uppercase A apple again, and we can see that now the A is gone. It's just PPLE, and I have two vowels in this word because the A is included. Right? Because at that place where it's working, it's taking whatever letter is at that index location, making it lowercase temporarily, and checking to see if that lowercase version of that letter is in my sequence of vowels. Which is significant. That gives us a lot more flexibility, right? That's going to help us out a ton. So what I'm going to do now is I'm going to create a new file here, and I'm going to call it automated string.py. But you know what? I'm going to make it shorter than that. I'm going to call it astr.py. because since it's another file, I actually have to run that with the Python command here in the shell. So we'll add our shebang. And what I'd like to do here is I'd like to take this and I'd like to take this here where we have reversed this, or where we've gotten rid of this value A, and I'd like to do it automated. And I can automate that with our replace function. Replace is an inbuilt function in Python that essentially just goes through and does what we were just doing there with removing the letter. Just somebody else already did it for us, right? We can see here we start with some string that we put into a variable called y. And then in a new variable, we're putting a y.replace s with y. So when we print that out, every instance of s becomes an instance of y. The important thing to remember here is that it's returning a copy. So if we do this, we have to put it in some sort of variable, like we're doing here in this example here that's on the slide. So let's create a function. Let's call it replace letter. And let's address a word as an argument here. And so we've already got word. And so all we really need to do here is say new word equals word.replace A's with nothing. And if we wanted to like take this even further, right, we could say, oh, word dot lower dot replace. So in this instance, we'd be taking the word, we'd be making the word lowercase, and then we'd be replacing all the A's with nothing. So then all we'd have to do is print this new word, and we will have done what we did there before. We will have just done it in an automated fashion. So we can put our main gate here, if name main. We can run an input, w equals input, enter a word for replacement. And then we can call that function replace letter with w. Right, so now if we run this, which will run astr.py, or rather Python astr.py, enter our word for replacement. Let's do that capital A apple again, and we'll see we get PPLE, right? Because we're making it all lowercase. So any uppercase A's that are in the word get converted to lowercase, and then we're replacing any lowercase A's with empty strings, with nothing. Right, so that takes what we did here manually and automates it, which is pretty cool. The other half of this is to use the find method. And the find method can find a character or substring in an existing word, and it will tell you the starting index location of where that is. Right? So one of the things that we have to remember here is that if we're dealing with this, then it's going to start at 0 because our first index location is 0. If it does not find the character in there, it's going to return -1 to you, just meaning that it doesn't exist. So this would be an interesting way to see if a character is in a word or not, because it's either going to return to you something that is between 0 and infinity, if it's there, or it's going to return to you -1 if it's not. And that's with our .find method. So we're just taking, in this case, we're taking our word, which is a word string with, or a word variable with a string inside, and we're using it to find the substring NA. So, for example, if our word is banana, and we execute this word.find NA, it's going to find the first instance of NA and give you the starting index location of that, which we see here is 2. That's 0, 1, 2. Right? If we specify the index location, that's where it's going to start looking. Right? So here in this other example, word.find NA3, that's going to start looking at index location 3. So that's 0, 1, 2, 3. So it's going to start looking here, which means that the first instance of NA after where it starts looking is next, which starts at index location 4. And so we get returned the value of 4. If we have a third argument here, that's where it should stop looking. So in this case, we're starting looking at 1, but we're stopping looking at 2. So that gives us an index range of 1 up to, but not including 2. So in this case, this is only looking at the O in the middle of the word Bob. And since that is not a B, that's an O, it's going to return to us as -1 because that search fails. Right? Whenever it fails to find it, it's going to give you a -1. And remember that, when we're dealing with these multiple values like this, the second value, it's going to go up to, but not include that variable value. So one of the last things that I want to talk about here is the immutability of strings. So it's important for us to understand the immutability of strings. What does it mean for something to be immutable? Immutable means that it cannot be changed. So once we create a string in Python, it is unable to be changed, which is why we have to do all the things with the new variables and concatenating with new variables and all that kind of stuff to change the string. We cannot do it in place. Right? So what you might want to do is do something like we see here, where we just kind of address some house, some index location there, evict the character that lives in there, and put a new character in there by doing reassignment. We can't do that with a string. We can do that with a list, which is our next module, but not with a string. And so how we replace characters with the string is the way that we just looked at, using our find and replace functions, in addition to the manual method that we looked at earlier, where we used another variable to do a temporary store of data there. And so I think that's where we're going to stop for today. We're just a little over the hour mark. There are a few other things in your module that we didn't cover here, but I think I hit all the high parts for what you will need to complete your assignments, your lab assignments for this module. So we'll leave it there. I will turn on the music for just another minute or two and hang out in chat just in case there are any questions for anybody here with me live. But again, that's all that I have for you for today. Thank you for watching. We'll see you next time.